Z.AI's GLM 5.2 is a massive 744 billion parameter open-source model optimized specifically for complex coding tasks. It performs on par with closed-source frontier models. Our goal today is to pull that immense architecture out of the cloud and run it entirely locally. That means no API keys, no subscription tiers, and complete data privacy. But you need to know upfront, the hardware barrier here is extreme. This workload will instantly overwhelm any standard consumer laptop. To run the compressed 2-bit version of this model, the cleanest target is an Apple Mac Studio with at least 256 gigabytes of unified memory. If you are building a PC for this, you are looking at pairing massive amounts of DDR5 system RAM with multiple high-capacity GPUs to handle the data load. It is a heavy hardware investment, but clearing that hurdle gives you unlimited private access to a frontier-level intellect sitting right on your desk. To actually fit this 1.5 terabyte monolith onto local hardware, we rely on Unsloth dynamic quants. These compression files shrink the model's footprint by allocating fewer bits to less critical neural pathways. This data table lays out exact memory requirements. Looking at the 2-bit row, UDIQ2_M requires a minimum 245 gigabytes. For systems just under that, the 1-bit UDIQ1_S quant drops the requirement to 223 gigabytes, retaining 76% of its accuracy. Look at your machine's exact maximum memory capacity. Find the corresponding file name on this list and write it down. Precision here is non-negotiable. Exceed your limits by a fraction and you guarantee an immediate crash. To begin the installation, open your terminal and run pip install Unsloth Studio to set up the host environment. Once that finishes, launch the local server and navigate to your local host address in your web browser to open the UI. Inside the studio, go to the search bar and pull up the specific repository labeled Unsloth/GLM 5.2 GGUF. Select the exact quant you wrote down earlier and initiate the download. Prepare to wait. The 2-bit file is a 239 gigabyte payload, and depending on your connection, it will take significant time to pull down. You are executing the literal transfer of an intelligence scale normally reserved for corporate data centers directly onto your local drive. Before we start the model, we have to bypass 2 fatal deployment traps. First, for Apple Silicon users, macOS aggressively pages memory when applications touch more than 85% of unified RAM, triggering an immediate kernel panic. To prevent this, you must run this exact sysctl command in your terminal. This hardwires the memory limit, stabilizing the system for the massive allocation. The second trap affects anyone using a visual interface. There is a known syntax bug buried inside the model's default chat template that causes a silent inference failure. The default Jinja2 template uses an invalid numeric index for array access, specifically calling out the phrase m.content.0. Open the chat template settings and locate that phrase. Delete the dot and the 0 and replace it with standard bracket notation, m.content_0. Without applying these 2 obscure technical patches, your system will either crash or freeze silently. With them, the path to a functional 744 billion parameter model is clear. Load the model into memory. In your inference settings, ensure the internal thinking parameter is explicitly toggled to high or max. To test it, prompt the model to write a Python script for the Fibonacci sequence and to calculate its time and space complexity. The moment you hit enter, you will see a massive immediate surge in both your system RAM and VRAM utilization as the model activates. When that first generated token finally appears on your screen, you have successfully cold-started a localized frontier intellect. You now have highly capable code generation and deep reasoning executing completely offline. This dial shows the harsh reality of running a model this large on a desktop. Your generation speed will be locked between 3 and 9 tokens per second. If you are used to the blistering output of cloud APIs, this will feel incredibly slow. It is simply not designed to be a snappy, interactive chat partner. But that deliberate pace is perfect for deep, asynchronous work. By connecting this local endpoint to an autonomous framework like Hermes Agent, you shift the workload. You can hand it a massive refactoring job, go to sleep, and let the model grind through the codebase overnight. A slow, highly capable local model gives you a free, tireless worker, scaling your output without ever touching a cloud server.